Hi, this is Lab 5 about reduction of multiple subsystems. Part A is complex system which is consists of multiple subsystems. We need to construct the system using Simulink in MATLAB. This is a step block which generates step function. It provides a step between two definable levels at a specific time. Then a sum block to add input to integrator with 1 over x and gain with phi. Before the integrator, the gain of phi is added to next system, and a gain of phi is feedback to the system. This system is added to integrator 1 over x and feedback with gain of 2. Then the system is added with gain of 6 and combined with next system with integrator 1 over x, and the feedback is gain of 3. The system response is shown in scope. This is a graph with the system after the system is simplified.
Good day, my name is Guan Wei, and I will be presenting about the Mason rules part. So as we can see here, through the calculation, as we have already found out that derived the graph and the figure from our experiment. This will be our final form for us to continue to do the Mason rule. And first of all, we're going to find three important stuff, which one of which is the forward path, loop gains, and also the non-touching loops. And from this figure here, we can actually tell that we are going to have three different non-touching loops, and we're going to be having these three multiplied together at a time. So for the first one, the forward path, which are the T1 and also the T2 here, G1, either G1, G3, G4, G5, G6, or as we can see here, G1, G3, G4, G5, G6, as I said just now, or we can use this one on the G2, following this curve here, G2, G4, G5, G6. This will be our forward path. The next one we're going to take out the loop gains. So here we are going to be having three different loop gains, which are basically just H1, G1, and G4, H2, and the G6, H3. This is why this is not considered as the loop, because this is not actually for the loop gain. This is actually for the forward path. Then we're going to talk about taking the non-touching loops. As we can, it is actually a set of the formularity. So we just need to use this. We just need to take this loop to multiply with this two, and after that we just repeat the same thing. But since if we multiply again by using this to multiply this and this again, there will be some repetitions. So we just eliminate the other repetitions and take the others that are not in repetition. And then lastly, we're going to do the non-touching loops for the three. Then take it three at times. So these three, the G1, H1, G4, H2, and G6, H3, and three of them are going to multiply together. The next time we're going to do, what we're going to do is that we're going to find the delta. And then to find the delta, the formula of the delta is actually 1 minus the loops plus the loops that are taken 2 at a time, and also lastly 2 minus the last one, which is the loop that is taken 3 at a time. So all we have to do is just substitute all this values in it. So since the first one is just basically this 3, no, not this 3, sorry. So the first one is going to be this all 3 loops to be added together, to be deducted by 1, and then we're going to add on the loops that are taken 2 at a time, and also lastly for this, which is the non-touching loops for that is taken 3 at a time. As we can see here, after we found out the delta, we're going to look for another thing, which is to look, is there any loop that is outside of the loop of our from our loop. Since there is no other loop on the outside, like right over here or here, so we just basically just use this one, delta 1 to delta 1 will be equivalent to 1 minus 0, and delta 2 will be the same thing again, because they're not having any extra loops outside, so the value will be just 0. And then then we're gonna put them in this. We're gonna use this formula to find out the value of it. It's gonna be CS over RS. The CS is just gonna be T1 delta 1 plus T2 delta 2, and this two, they're gonna be divided by the delta. And then for the T1 delta 1, the T1 delta 1 is going to be G2, G4, G5, G6, which we can see is actually this one, the T1, the G2, G4, G5, G6. But it's going to be multiplied with the delta 1. And then for the second one, which is the T2, is going to be this G1, G3, G4, G5, G6 is going to be multiplied with the delta 2, which is also 1. So it's going to be G2, G4, G5, G6 plus G1, G3, G4, G5, G6. And these two are going to be divided by the delta, which is this. And then to simplify, since the steps are taken until here, so we can't really simplify it. So in order to simplify, we just need to substitute all the values, like for example this one. For example, for this, the G1, G4, G6. So the G1, G4, G6 is going to be 1 over S, while the G2, G3, since the value has already been assigned, like early on, G2, G3 is going to be 5. And then the G5, and then the G5, 6, H1, negative 5, H2, negative 5. Then just substitute, and then we get the final answer from here. But as we can see here, since our denominator has the fraction, the denominator of the fraction inside of this fraction has the S, which is not a good thing for us because we wanted to simplify it. So what we're gonna do, we're gonna just take the one with the largest exponential, and to do this conjugation, and then after that, lastly, we're gonna this will be our final answer. Next up, we're going to talk about the simulation. After we found out the final value for the Mason's rule for this figure, we just simply need to put a sketch and use the Simulink to create to make it display the value through the sine graph. So here will be the value that we calculated, and this will be our final output.
I will present for part B, reductions of block diagram method. This is the figure that provided in the lab sheet. First, we will replace the value with the G1, G2, G3, G4, G5, and G6, and H1, H2, and H3. Then we will move the peak off point to the right of the G1, and we will get G2 over G1. After that, we will combine the feedback of G1, H1, and we will get G1 over 1 plus G1, H1. Then for G2 over G1 and G3, we will get G2 over G1 plus G3. For the feedback of G4, H2, we will get G4 over 1 plus G4, H2. Then G5 will maintain, and the G6 and H3 for the feedback is G6 over 1 plus G6, H3. Then now we will get the cascaded form. We will do the calculation to get CS over RS by multiply the G1 over 1 plus G1 H1 with the G2 plus G1 G3 over G1, multiply with the G4 over 1 plus G4 H2, multiply with G5, and multiply with G6 over 1 plus G6 H3. Then we will cancel out the G1, and we will get G2 G4 plus G1 G3 G4 divided by the 1 plus G4 H2 plus G1 H1 plus G1 G4 H1 H2, then multiply with the G5 G6 divided by 1 plus G6 H3. Then we multiply these two, and we will get these equations. After that, we will substitute the G1 equals to G4 equal to G6 equal to 1 over whereas G2 equal to G3 equal to H1 equal to 5, G5 equal to 6, H2 equal to 2, H3 equal to 3 into the transfer function that we will already get. Hence, we will get the CS over RS is equal to 30S plus 30 divided by S power of 3 plus 10 S power of 2 plus 31S plus 30. Then, this transfer function we will use in the Simulink. This is the Simulink block that already created. Then we will now to see the output response of the system. Then we run the circuit. To see the output response, we will click the scope. Hence, this is the output response of our system. That's all from me. Thank you.